So in this video, we're going to show you one method of how we can solve these system of equations. And this method is called the graphing method. We've got here our two equations. Do you recognize that form? If you recognize these equations as being slope-intercept form of a line, you're absolutely correct. In our first equation, the slope, which is the coefficient in front of x, is 1. So that means that if we think of that as rise over run, or if we think of it as fraction, then we're going to go up 1 and right 1. And then our y-intercept is 0, 1. So then I'm going to come over here to my graph and I'm going to graph that first line using that information. So here's my starting point of 0, 1, and then I'm going to go up 1 and over 1, up 1 and right 1, up 1 and right 1. And our second equation is also in slope-intercept form, and we've got this time that our slope is negative 2 over 3. So we're going to go down 2, right 3, and here's our y-intercept 0, 6. So let's make it a different color here. So we have here's 0, 6, and we're going to go down 2 and over 3. Now notice what just happened. This is kind of cool. So notice now that I've graphed both lines on the graph paper. And when we're talking about solving this system, we're talking about finding this point of intersection, the point where the two lines meet. And so these two lines meet at the point 3, 4. So I went up over 3 and up 4. Okay, and this is our point of intersection. And so that means that when I substitute this order pair into each equation, it should make both equations true. So let's do that really quickly. So here's our first equation. 4 equals 3 plus 1. That does check. And our second equation, that order pair 3, 4 satisfies both equations, which means that it's the solution of the system, and we can tell it's the only solution because basically these two lines are only going to cross at that one point. Now let me introduce you to some vocabulary, some math vocabulary. Okay, so when we have a system of equations such as this one that does have a solution, so the two lines do meet, then we call that a consistent system. Consistent system. And because the two original lines are different lines, right? The pink line and the purple line are different lines. We call those independent lines. So as part of your homework, you may be asked to categorize your system. And so know now that when two lines meet at one point of intersection, such as this one, we call that a consistent system, independent lines. Okay, we're going to go to number 2. And here in number 2, do you recognize these two equations? These are lines in standard form. Standard form. Again, we're going to graph both of these lines and see where they intersect. So, because they're in standard form, how about if we find the intercepts so that we can graph using the intercepts, because when the lines are in standard form, that can be easy, right? So, just a reminder, to find the y-intercept, you set x equal to 0 and solve for y, and to find the x-intercept, you set y equal to 0 and solve for x. So in this first equation here, if I set x to 0, I will get, so here's equation number 1, right? 4 times 0 minus 3y equals negative 18. So I get y equals 6 when I divide both sides by negative 3. So I now know that 0, 6. So let's graph that. So here's 0, 6. That's the y-intercept of equation 1. Let's now substitute 0 for y. And now I'm going to get a fraction, but I'm going to get x equals negative 18 divided by 4, which reduces to negative 9 halves, or negative 4.5, right? So now I'm going to, let's actually put that there, negative 4.5 or 4.50. So now I'm going to come over here and graph that order pair, and now I will join those two. Okay, so there's our first line. Now I'm going to repeat the process with the second line. Let me get a different color. This is line number 2, so this was line number 1. And in line number 2, if we set y to 0, or x to 0, let's start there. 2 times 0 plus y equals negative 4. Then we get 0, negative 4 as our y-intercept. And then if we set y to 0, now we're going to get that x equals negative 2. So negative 2, 0. So there we go. There are the two intercepts. And I'm going to join these with a line. Get your ruler out. Okay. So where's the point of intersection? It looks like it's right here. The order pair negative 3, 2. Negative 3, 2. And we'll check it just in case, one of the things about graphing lines is that if you're off by a little bit, then maybe your answer won't be accurate. So it's always good to check. So 4 times negative 3 minus 3 times 2, that's negative 12, minus 6, that does equal negative 18. So our point does work in our first equation. And then 2 times negative 3 plus 2, that's negative 6 plus 2, and that equals negative 4, and so that checks as well. So one thing, the solution is negative 3, 2. Okay, that order pair, because you're finding where the two lines cross, where they intersect. That's the point of intersection. What type of a system is it? Well, it's still consistent because there's a solution. We found a solution, so we say it's consistent. And then the two lines are not the same, so we call those independent. So that's the category. This is our answer right here. Alright, and in this next problem, we once again have two lines in standard form. So we'll go ahead and find intercepts. Here's line number 1, and when we set x to 0, then we get negative 3y equals 3, or y equals negative 1. So we have the 0, negative 1 as one intercept. 0, negative 1, that's the y-intercept. Then when we set y to 0, we get x equals 3. You see that? X equals 3. So 3, 0 is our other intercept. Okay, and then we're going to do the same thing with the second problem. So when x is 0, now I get negative 9y equals negative 18, or y equals 2. So 0, 2. And then when y is 0, we get 3x equals negative 18, or x equals negative 6, so negative 6, 0. Okay, very good. And then, okay, so tell me, what do you notice about these two lines? If you said they're parallel, you're absolutely right. These are parallel lines. So are these lines going to meet ever? No, they will not intersect, will they? There will be no point of intersection in this system. So that means that we have no solution to the system. Okay, so let's categorize these. When you have the parallel lines and you have no solution, those two lines do not meet, we call that an inconsistent system. Inconsistent system. And the lines, they're different, so they're independent. Okay, so no solution for this system because we've got parallel lines that do not intersect. Inconsistent system, independent lines. Alright, so again, these are in standard form, and so we're going to do the same thing. So x equals 0 here. When x is 0, we get y equals 3. So 0, 3 is an intercept. When y is 0, we get x equals 3 over 2. So 3 halves 0. And here's our line. Okay, so that's equation 1. Now let's look at equation 2. And when x is 0 here, we have 3y equals 9, so y equals 3. Oh, that's interesting. Maybe that's the point of intersection. Okay, and then when y is 0, now we get 6x equals 9. And when we divide by 6, we get x equals 3 halves. So 3 halves 0. So what is that? What's happening now? What's happening now is that these two lines overlap each other. We call those coincident lines. And that means that for these two equations, every single order pair that's on this line satisfies both equations, right? And how many order pairs, how many points are on this line? there's infinite, isn't it? I want to make sure you understand that when we draw a straight line, that these are composed of lots of little dots, little points, and they're so close together that they make a line, right? Because sometimes I've had students be confused about that idea. So there's infinite number of solutions. So these are the overlapping lines. These are the lines that lie one on top of the other. And we call that a consistent system because we have solutions. We have actually an infinite number of solutions, which are all the order pairs that are on those lines. But these two lines are dependent because they basically represent the same graph. Do you see that? So this is a consistent dependent system with an infinite number of solutions. So let's recap what we just learned. So here's a quick recap. To solve a system of linear equations by graphing, you're going to graph one equation for the first equation and then the second equation on the same rectangular coordinate system, so the same graph paper, so to speak. You're going to determine which of three different cases you have. Do you have the case where the two lines intersect at a single point, just like here in case number 1, and they intersect at this point right here, and then that point, that's one solution, and that will be the solution to that system? Or do you have case number 2 where your two lines are parallel lines? These have no points in common, these two lines, so there's no solution to the system. Or do you have the case where both equations give the same line? And because we have just one line, there's infinitely many solutions. Here's a nice little chart for you. In case number 1, this is our intersecting case. There's one solution, one order pair, and we call that consistent independent case. Case number 2, we have the parallel lines. There's no solution. The lines never meet. That's called the inconsistent independent case. Inconsistent, no solution. Independent lines because they're different. Coincident is the third case. That has infinitely many solutions. That's a consistent system because you have solutions, but the lines are dependent because they represent the same line.